All right, so we are live. We are going to do the examples for the rest of the uh, solving for logarithms and exponentials. Um, a lot of this is just the exponential part and how to solve using exponentials and then maybe switching some stuff into logs. A lot of this you've kind of already learned along the way, but it's a nice refresher just whenever you have some more complex types of problems. All right, so if you take a look at this problem here, the big thing that you want to do is you want to get this by itself. That's like your all-time goal. Because then what you can do is you can trade it from this into a log base type of problem. So I'm going to add 4 to both sides. And then divide by 2. I'm going to leave it as 15 over 2. You could also put 7.5. It really doesn't matter because you're going to see how you'll end up plugging that into a calculator. And as you can see now, it's in that b to the x equals y format. So I can move it into log base. Because I really can't think of anything times 2 minus 5 as an exponent that would give me 15 over 2. So log base 3 to the 15 over 2, or 7.5, equals 2t minus 5. So then next up, we're going to add 5, and then divide everything by 2 in order to get t by itself. Now, it's really, in your calculators, technically, you can't plug in log base 3 of 15 over 2, but you can use change of base. So I'm going to write this as though you were plugging it into your calculator. It's log of 15 over 2 divided by log of 3 plus 5 all over 2. This is how you will plug it into your calculator. So log 15 divided by 2 divided by log of 3. And then after that, I would hit enter just to get that unique decimal. And then plus 5. And then I would hit enter again. And then divide by 2. You should get 3.42. And I'll repeat that one more time for you. You can on some so the question was whether you can actually get the base. On some calculators you can, some of them you can't. So I want to show you at least this way. That way everybody has an idea. But if you have one of the newer ones, they're very nice. They will definitely help you out. Okay. So again, do log of 15 divided by 2 divided by log of 3, enter, and then plus 5, enter, divide by 2, enter. Questions at all? Okay, let's move to example 6. So again, our main goal is to get our base and our exponent completely alone by themselves. This is in my denominator. I'm going to move it by multiplying by it over to the other side. So I have 4 is equal to 8 times 3 minus e to 3x. So 4 is equal to 24 minus 8 e to the 3x. I'll subtract by 24. And divide by negative 8. I'll pause right there for a second if you're needing to catch up and kind of see some of the steps. Again, move everything over, multiplication, distribute, subtract 24, divide by -8. You get 5 over 2 is equal to e to the 3x. Now, here's the thing. Remember, e, okay, e is what makes ln, because e is the base of ln. So when I rearrange this, it's going to be ln, because that has a base of e, of 5 over 2 equals 3x. So kind of workaround, think of it as e is like makes natural log. So you could technically kind of put log e, but it's easier in your calculator ln to put that. So, and then you'll divide this by 3, and you'll get x to be, let's see here, ln divided by 2 divided by 3, 0.31. Not too bad. Questions at all? Got one more example problem for you. I told you this is going to be very quick. The last example problem, I'm going to show you something that might help you along on your certain types of standardized testing a little bit. And it's mainly just kind of like an eye thing, because some of you might be able to do this without using what I call U substitution. Others might be like, I need that because visually it's easier for me to see. This says e to the 2x minus 3e to the x minus 4 is equal to 0. To me, visually, it's difficult to be like, oh, I've got to factor that, but it's got e's in it. Well, why do that work? So let's go ahead and we're going to use something called U substitution. It means we're going to let u equal e to the x, and then we're going to substitute that in wherever we see e to the x. This is going to visually make it easier for us to factor. It's all based on a visual thing. So u squared minus 3u minus 4 equals 0. What's going to multiply to give us -4 and add to give us -3? U minus 4 and u plus 1. This also, by the way, will help you with the more difficult problems whenever you see these. So then you'll have u. Remember, if you set each of those equal to 0, you'll get u is equal to 4 and u is equal to -1. Since u is e to the x, we're going to plug e to the x back in because we do need to solve for our x variable. So e to the x is equal to 4. E to the x is equal to -1. And now this is where it changes into that ln, okay, that natural log. So we can say ln of 4 equals x because it's the e base, and ln of -1 equals x. Just as a reminder, ln or log of anything that's negative does not exist. So that answer is null and void. On the other side, though, ln of 4 will equal 1.39.